Access to clean and safe water is essential for public health, environmental sustainability, and economic development. This project is inspired by Sustainable Development Goal Seed, which is SDG Seed by the United Nations, which focus on ensuring the availability and sustainable management of water and sanitation for all. One of the biggest challenges in achieving this goal is the issue of non-revenue water, which is the difference between the water delivered and the water actually billed to consumer. High non-revenue water level can be caused by inaccurate meters or inefficient distribution system, and they lead to serious financial and resource losses. So, our mini project, developed using C++, aims to help solve this by analyzing water distribution data from different zones. It reads input from file or manual entries, calculate non-revenue water volume, non-revenue water percentage, and estimate financial losses in ringgit Malaysia. This system provides a simple but practical tool to help identify problem areas and make data-driven decisions, supporting our commitment to SDG SEED, which is the clean water and sanitation.
The objective of this project is to use C++ programming to solve real-life problems related to water loss. We apply basic C++ features like structure to store zone data, file input and output to read and save record, and use condition and loop to process and analyze the data. This helps us to detect areas where there is a big difference between water supply and bill, showing zones with high water loss.
First, we include some important libraries. IO string is used for input and output. F string is used to read from and write to files. S string helps split each line from the CSV file. Vector is used to store multiple data entries. And then, IOmanic is used for output formatting. The line using namespace std allows us to use C++ features without needing to write std every time. Next, we create a structure called zone data. This struct holds one full record of water data for a specific zone. It contains the first one is year, which is the year of the data, and the second one is zone, the name of the zone. Third is volume delivered and volume bill, which are water delivered and bill. Fourth is tariff cost, which is the price per unit of water. And then threshold, the maximum non-revenue water level allowed. And then the last one is three more fields for calculation letter, which are non-revenue volume, non-revenue percentage, and loss in RM. We also declare a global vector named water data. This is where all the zone records will be stored, whether they come from a file or entered manually. The function read from file reads data from a CSV file. It opens the file using if string, and then skip the first line, which is the header. Then reads each remaining line one by one. Each line is split using string stream and converted into the correct data types. Then, stored inside a zone data struct and pushed into the water data vector. At the end, it displays a message saying the data was read successfully. If there is no file, user can also manually input the data using the keyboard. In the read from keyboard function, first, the user is asked how many records they want to enter. Then, for each record, the program asks for the year, zone, water volume, tariff cost, and threshold. Each entry is stored inside a zone data struct and added to the water data vector. After that, the program confirms that the data has been successfully entered. So, that's all from me for this session. We have covered the data structure, reading from a file, and manual input. So, in the next part, we will look how to calculate loss percentage and monetary loss in RM.
The second function is calculate NRW. There is a for loop And there are three formulas that will be used here. The first formula is NRW volume equal to volume delivered subtracted from volume billed. Second, to calculate percentage of NRW volume will be divided with volume delivered times with 100 to get the percentage of NRW. Third, to calculate the cost of water loss, NRW volume will be multiplied by tariff cost, and the Cout is NRW calculations completed will be displayed at console. Next, the third function is to display the result in table format and bar chart. At the Cout, there is set precision 2, meaning we set the result to give us only 2 decimal points. The result will be displayed here: zone, volume of water supply, volume of water bill, NRW water and its percentage, and the cost. The zone with NRW percentage which greater than 20% threshold will be display alert status. Otherwise, OK status will be displayed. At line 95, the bar chart based on water loss will be displayed by hashtag symbol. For loop is used in this case. The loops will be continuous as long as I is less than the value stored in the bar variable. At the top of this slide is the result from the second function. If the user enters 2, the NRW calculation will be calculated and will be displayed NRW calculations completed. The bottom picture shows the result from the third function in the table form and also bar chart. There is bar chart with the hashtag symbol in the bottom of the zone name, and each hashtag will be represent 10 ringgit.
Okay, now for this part, I will explain the save to file function. This function is used to save all the data and result into a CSV file. For example, in this project, we save as output.csv. At the first of the function, we open a file using OFstream. Then we write the column header like year, zone, volume delivered, volume bill, tariff cost, and so on. After that, we use a for loop to go through every record in the water data vector and write all the values to the file line by line. Okay, at the end, the file is closed using out.close, and this program will display a success message to let the user know the saving was successful. This is the result that's saved in the output.csv file. It can be opened using software like Microsoft Excel or Notepad. As you can see here, each row represents one zone, and it contains important data like the year, the name, supply volume, bid volume, NRW percentage, and total RM loss. And the most important is the zone status, whether it's OK or alert. Next, this is the main function, which are the central part of this program. In this function, we display a menu to the user, allowing them to choose an action. We make 1 until 5 choices, which are read data, calculate NRW, display the result, save result to file, and exit the program. The program reads the user's choice using cin and read choice. And then we use a switch case structure to call the approximate function. This loop continues running until the user chooses option 5 to exit. This is an example on how the output appears in the terminal when the program is running. The user begins by selecting how they want to input the data, either by reading from a CSV file or entering it manually. If reading from a file, the program will ask for the file name and load the data automatically. If entering manually, the user input the number of record and fill in the detail. After the data is collected, the user can calculate the NRW, display the result with a bar chart showing the RM losses across zone, and save the output to a CSV file. The main function controls this entire process step by step, guiding the user through each menu option, starting from data input choice 1, choice 2, choice 3, choice 4 until they choose to exit, which is choice 5.
The conclusion is our analyzer successfully evaluated key metrics such as non-revenue water, volume supply, volume bill, financial loss, and providing data of inefficiency of distribution of water. This project not only strengthened our C++ programming skills, but also offer paths towards sustainable resource management. That's all from us. Thank you for your time.